this part of the tutorial, we're going to introduce floats and doubles in Android. So we're going to do that by declaring and initializing a couple of floats and doubles, and we're going to compare them to integers. So we're going to perform some operations, and we're going to see what happens when we try to add floats and doubles together, because something very interesting happens. Now we're going to take a look at floats and doubles in the Android part of Xamarin instead of iOS. Now they're pretty much the same, so far we've seen integers, let's say in I equals 5, and now we're going to take a look at floats, let's say float f equals 10.50, and let's create a double too, we'll call this d, and we'll give it the value of 0 and a bunch of 3's. So, now let's recap the differences. So integers can be positive, negative, or 0, but cannot contain decimal places. Floats can contain decimal places and are accurate for up to 7 digits. Now the decimal could be here, or it could be right at the end. It doesn't really matter where the decimal is, but there will be a maximum of 7 digits being displayed. So if we have something like this, then it will basically just cut off all of the digits up to this point. So again, it will only display 7 digits. And another thing to note about floats is that they have the F on the end to signify that they're a float, because otherwise our compiler will recognize any other decimal number as a double and it will throw a complaint. So now let's take a look at doubles again. Doubles are accurate for up to 12 decimal places, 14 decimal places. Here we have a few more than 14, so it would cut off at, let's see, so we've got 2, 4, 6, 8, 10, 12, 14. So it would cut off these 3's and leave these ones. So this is the difference between the 3, and let's see if we can perform some arithmetic with a 3. So let's go ahead and create a double, and we'll call this result, and result will be the result of f plus d. So this is taking a float and adding to a double. And now let's see what happens, because the results are a little interesting. Say result, and again we have to convert this to string. Alright, let's go ahead and run this. So we get this warning here because in I is never used, and that's fine. We know it's not going to be used. So here we get the result, 10.8, and then a bunch of 3's printed out, and that just means that we can actually add the float and double no problem. Let's see what happens if we change the type to a float. So let's stop this and rerun it. Here we go. See, this is where we get the issues. So although a double can be the result of a float plus a double, the float cannot be the result of a float plus a double. If we wanted to do this, we'd have to do what's called typecasting. So we'd have to cast our double to a float, which is something we cannot do. So the takeaway of this is basically, if we want to add floats and doubles, you have to store it in a double type variable rather than a float, or else you have to do what's called typecasting, and that's a little more complicated. So another takeaway point is, again, doubles are extremely precise. We'd rarely need this level of precision unless we were dealing with extremely small numbers or extremely large numbers. For scenarios like a bank account where at most you'd have 2 decimal places, it might be more appropriate to use a float as they take up a little less room in memory, but doubles are needed to perform arithmetic operations such as this one here. So we saw this in the iOS tutorial where we take two numbers, let's say 5 and a 2, and we'd have to store this in a result, so then we could say double result is this. The result of 5 raised to the power of 2, because that's what this function is doing, 5 raised to the power of 2. And so this takes in two doubles rather than two floats. And in fact, most of the math operations do. So if we say math dot, and then these are all of these different functions we can take in. These ones take in bytes. This one's a log function. If we see on the right here, it takes in doubles. Exponential function takes in doubles. And so yeah, there's a big list of built-in functions here. Most of them are taking in doubles. So it might be a good idea to, in your code, stick to integers and doubles rather than floats where possible, if you're performing these kind of arithmetic operations. In this part of our tutorial, we took a look at floats and doubles in Android. So we did this by creating a couple of variables and forming some arithmetic operations on them. From this, we saw that we can convert floats to doubles, but we have to cast if we want to convert doubles to floats. We also saw that a lot of arithmetic operations, the built-in math functions, take in doubles. So although doubles can bring an unnecessarily large amount of precision, they are used in lots of operations in Xamarin, so it might be best to stick to ints and doubles rather than floats. So by now you should be able to explain the difference between integers, floats, and doubles, the three ways of representing numbers, and give some examples of each and where we would use them in the code and in real life.